In this video, we're going to go through the beginning of volume and surface area, but before we do that, we need to talk about 3D figures and solids and what the names of them are and some other different definitions. So, first off, in our figure right here on the right, that this is a polyhedron, and a polyhedron is a solid that is bounded by polygons. That just means that all of the sides do not have any curves, and because remember what a polygon is that there's no curves and there's no open, so it's a closed figure. And those sides, the bounded polygons, the polygons are called the faces of our figure, and they enclose a single region of space. So if you notice all of these spaces over here, that there's one in the front, one in the back, two on the sides, one on the bottom, and one on the top for the faces in this figure. The next thing you'll be asked to identify is an edge. So an edge of a polyhedron is a line segment formed by the intersection of two faces. So think of if you were going to make a figure out of toothpicks and we're going to hold them together with little marshmallows, that the toothpicks would be each of the edges. So all of these straight lines are the edges. Lastly, the last word that we're going to talk about is a vertex. We talked about a vertex before, but a vertex in here is where two or three or more edges are going to meet. So if you think about it, that's where each of these different points are. So if I was holding marshmallows together, that the marshmallows themselves would be the vertex or the vertices. And these figures down here, we are talking about the different types of solids. So there's polyhedrons and there are non-polyhedrons. So if you notice, what are the differences? Here, a prism and a pyramid are polyhedrous, and a non-polyhedra would be a cylinder, cone, or a sphere. If you notice, it's because there's curved edges. We will still be finding the volume and surface area of these different figures, but just to classify them into two different types of solids. So next up is a prism and pyramid, so the two that we just saw. A prism, just so you know what that is, it has two bases that are congruent polygons in parallel lines. They're parallel to each other. So if you notice, the pentagons right here, so the top and bottom, are the only two sides, the only two faces that are parallel to each other. So those are the bases. So when we name a prism, we have to use the shape of the base. Sorry about that. The shape of the base to label it. So in this one, because the bases are pentagons, this would be a pentagonal prism. So now when we're talking about a pyramid, we only have one base, and it's not parallel to anything. So in this one on the right, the triangle at the bottom is the shape of our base, and we also use the base itself to name our shape. So in this one, since it's a triangle, this would be a triangular pyramid. So we've talked about faces, vertices, and edges and what they are in our figures. And Euler's theorem basically says that if we add the faces and vertices together, it should equal the edges plus two more. So if we take the number of faces, which the letter in our equation for faces is going to be the F, and our vertices, which will be V, and our edges, which is the E in our equation, then they're related by this formula. So we're going to be using this formula to check to see if when you give me the name or the number of the edges, vertices, and faces, you can check to see if you're correct. All right, so in each of these four, we're going to be listing out a bunch of different things. First off, we have to say if it's a polyhedron or not. So let's go through all of those first. So for the polyhedron, remember there can be no curved edges to any of your figures. So in the first one, it is a polyhedron. In our pyramid picture right here, it is a polyhedron as well. In our next figure, this little kind of trough looking thing, it is not a polyhedron because it has a curved edge to it. And then for the last one, it is a polyhedron because there are all straight edges to them. All right, so next up we need to name the polyhedron, those that are a polyhedron. So this first one, because the bases are rectangles, it is a rectangular prism. And the reason I know it is a prism is because I have two sides or two faces that are parallel to each other and they are congruent to each other. So I really could look at these two rectangles in the front and the back, or they could be on the bottom and top. It just depends on how you want to look at it. So the next one for our pyramid, it is a square on the bottom. So this is a square pyramid. All right, for the next one, because it's not a polyhedron, we're pretty much done with that one. For the last one, this one is a little tricky and is going to happen often, but the two sides, the two faces that are congruent are really the triangles. So even though it's not on the bottom, the triangles are the basis, and because they are triangles, this would be a triangular prism. And why don't you go ahead and put a little star next to that one, because that name and that shape is going to happen pretty often. So next up, we need to go through and we need to label or come up with a number of faces, vertices, and edges. So I'm going to set up my paper like that. So when we go through and count this up, we are going to count the faces first. Remember, those are all the flat sides of our shape. So come up with a pattern. So the faces would be, if I have my bases, would be the front and the back. Then I have the bottom and the top, and then the two sides, the right and left side. So together for the faces, I have 6 faces. Next, the vertices are the points that hold them all together, so not the edges of the flat lines. So think of the dots on the corners. So I have 4 corners right here, and I have 4 corners back here, and that is it. So for the vertices, I only have 8. The edges are the lines that connect them together. So remember, I have 4 up here in front, 4 in the back, so that's 8, and then I have 4 that connect the two bases together. So that's usually how I think of it. I think of the two bases first because they're going to be the same, and then think of how many lines connect them together. So our edges, we have 12 edges. All right, so going on to our pyramid next, with our square pyramid, our number of faces is we have the base, so that's 1, and then because there's 4 sides, we have 4 other faces that lean together at the top. So this would be a total of 5 faces, the base and then 4 other sides. For the vertices, remember the points, we have 4 points for our base, and then there's just one more at the very, very top. So this is 5 vertices. For the edges, I also have 4 pieces for my edges at the very bottom, and then I have 4 coming up to make a point at the top. So there's a total of 8 edges for that pyramid. All right, so if we're down here in the lower right, we have the faces, we have 1, 2 for the bases, and then 1, 2, 3 for the other 3 sides that connect the bases together. So that'd be a total of, let's see, 1, 2, 3, 4, 5 faces. For the vertices then, we have the 3 for the base, so 1, 2, 3, 1, 2, 3, so there's 6, and that's it. So 3 for each of the bases, and then there's no more. For the edges, we have the 3 that make up our triangles, so that's 6 total, and then 3 more that connect the bases together, so for a total of 9 edges. So lastly, we need to check our answer using Euler's theorem. So remember his theorem from the front side, or on your paper is the previous slide. We have F plus V equals E plus 2. So now we're going to take each of our numbers and plug that in there and just check to see if the left side is equal to the right. That will verify that our answers in blue are correct. So for the first one is F plus V, so 6 plus 8 equals my E plus 2, so 12 plus 2. So 6 plus 8 is 14, 12 plus 2 is 14. So if this is correct, then I know that all of these numbers are correct. For the pyramid, next we're taking our F plus V, so 5 plus 5 equals E plus 2, so 8 plus 2, so that'd be 10 equals, oops, there we go, 10, and it is correct again, so we know that all those work as well. So lastly, for the faces, vertices, and edges of the triangular prism, we have 5 plus 6 equals 9 plus 2, so 11 equals 11, so that works. We know then that all 3 of these are working as well. Next up, this is just a few more definitions. So regular polyhedron means that all of the faces are congruent regular polygons. So looking at this prism right here, and one of the sides is missing right there, but you can kind of see it. But if you look at it, all of these segment lines are congruent, and all those triangles then are going to be congruent triangles. So that's a regular polyhedron. If it's concave and convex, you have to think of what we had talked about before with concave and convex. Concave means that there's a section that caves in, so that would be the second figure. And the convex means that there are no sides that cave in, so that would be my first figure up here with my regular polyhedron. All right, so looking at our examples to determine if it's concave or convex, if you see any parts that cave in, not just flat, but that they cave in from different sides, that's our concave. So concave would be this one and this one. So our second and third one, because of that section right there. And if you look right here, that right there caves in. And then the only one that is convex is this very first one, because it is flat right here. If you notice, like this little section, it is flat, but it doesn't cave in. There's not a little hole or cave in the side of our figure. This is the last slide, and this is talking about a cross section. So a cross section, it means there's an intersection of a plane and a solid. So think of a 3D figure, and you're taking like a piece of paper and slicing it open. And what is the shape that is created when you slice it open? Or what's the shape that you can see? So in this first one, in this picture shown, we have a pyramid right here, and there is a plane that's cutting it straight across, and because it's parallel with the base, it's going to be the same size shape as the base. So it's going to be a triangular cross-section. So we're going to do the same thing with these next 6 figures, because it just takes practice to see them, and it helps on these because it's in color, but remember on the test you're not going to have to color, or you won't have the color version. So if you look at this first one, we can see that the cross-section is right here, so this is part in purple, and it's parallel with the base. That means it's the same size as the base, so this is going to be a square. For the next one, because it's a cube and it's going diagonally, if you look at it, it's not going to be a square anymore. This is going to be a rectangle. And if we take it kind of at a different angle, so it's wider at the top but smaller at the bottom, this is going to be a trapezoid. For the next cube question, it's like I'm chopping off the corner, and so the part that's going to be exposed is going to be a triangle. Next we have a cone, and this is parallel to the base. So because we know the base, if you think of like an ice cream cone, it's the shape of a circle, so it's going to be the same size as that, so it's going to be a circle. If we did it at a diagonal, so if we had a cone, you did it at a diagonal, it would actually be an ellipse, or you can think of an oval. So then it may not be a circle anymore if it's at a diagonal. All right, for the last figure on here, you can see the part in purple. So it's a hexagonal prism, because it's a prism and the base is a hexagon. So when we cut it through and it's parallel to the base, just like it was with a square, and with our pyramid up here, if it's parallel to the base, it's the same shape as the base, so it's going to be a hexagon. So just get used to seeing those so that when you see one like that on the test, you know what to do.